Hello, my name is Justin Kramer, and this is my Slicer segment editor tutorial. You may have gotten here through the SIM 2018 conference, but if not, all the contents for this tutorial are linked to at the following site, neurorad.site/3d. There's several other tutorials on there as well. So this is where we're going. On this tutorial, we want to segment out a CTA of the heart and end up with a heart model. Here we see the left side of the heart in red and the right side of the heart in blue. So that's where we're ending up, but I'm going to close this out for now and we're going to work on getting there. Okay, so the first thing you're going to want is the files to do the segmenting with, and those are at neurorad.link/sim18 files. That's going to link you to a Google Drive folder that has files to download. This walkthrough document basically just says refer to the website at neurorad.site, so not too useful. Otherwise, you'll notice there's three folders. There's the Slicer folder. That's what we're going to be working from. The STL folder is going to contain the final files from the segmentation, and then Simplify3D is going to contain a G-code file that you can then use to print on a 3D printer. Okay, so just a couple things first. I went ahead and downloaded the files that we're going to be using to my computer. So you can see that there are 5 folders, and we have a 00 beginning folder, and that's what we're going to work out of. But just kind of like a cooking show, I have several steps along the way prepared as well, so that you can kind of rejoin the tutorial if you fall behind. So in the 01 folder, we have the right and left blood pool segmented, so just the inside of the ventricles and the atria. In the 02 folder, we have the right heart myocardium created. In the 03 folder, we've segmented out the left ventricle myocardium. And then in the 04 folder, we have the final segmentation where we have the right and left heart myocardium completely segmented and ready to be exported. You'll notice here too there's a cta.nii file. It's pretty big, 240 megabytes. This is a full CTA of the chest. So you might wonder what this NII file is. It's called a Nifty format, and I create Nifty files using the DICOM to NII tool. You can just search for DICOM to NII. This is a web page where you can download the software. It works pretty easily. It's not a super intuitive user interface, but it's very simple. So you just click File, DICOM to Nifty, and you point it to a folder containing DICOM files, and it'll just spit out a Nifty file. So we're going to be using 3D Slicer. This is free open source software supported by the NIH and still under active development after 2 decades. It's really powerful for all sorts of quantitative imaging applications, but we're going to be using it to segment out an imaging study and create an STL file that we can then print. So if you haven't already, you'll want to get 3D Slicer's software and download it. I tend to install the nightly build versions, but you're just fine installing version 4.8.1 also. So go ahead and get that installed and come back when you're ready. So I'm going to get started by opening up Slicer. So this is what Slicer looks like. And the first thing we're going to do is we're going to load our CTA. And so I'm going to add data. There is a DICOM import module as well, but since we have it in Nifty, we can just select a single file to add and pick the cta.nifty file. Load it up. All right. And so this is the Slicer interface. So I really just want to see this one window for now. So what I'm going to do is I'm going to choose my window configuration. You can see there's a lot of different options. Right now we're in the 4-up option. I'm going to go to red slice only. The red slice is usually the axial slice, and you can see you can use the slider bar up here to slide through if you want, or you can just scroll through. If you left click, you can window and level, and if you right click, you can zoom. The next thing to realize is how Slicer is organized, and Slicer basically is organized as a series of modules. And there are numerous different ways to access the same module often. So we're going to be using the segment editor module. You can see that there's a link to it at the top bar here, but you can also get to it as a frequently used module here, or you can find it in the segmentation submenu as the segment editor, or you can go into all modules and find the segment editor module there as well. They're all the same. And now we're in the segment editor module. Segmentation usually starts by adding segments. Add new empty segment. So we can do that first so that we can start to explore some of the tools. You can see here that the segmentation is called segmentation. That's fine to just leave that way. Our master volume is a CTA, and that's what we imported with cta.nii. And I'm going to add a couple different segments. All right. So I'm going to add a right blood segment and a left blood segment. And I'll explain why we're doing this in a second. And since it's the right side of the body, I'm going to color that as a vein. So you click on that little color icon and you can select vein, and then the left side of the heart I'm going to color as an artery. So then you're going to see there's a lot of different tools you can use to do segmentations with. We'll go over the paint and erase modules in just a second. And there's a couple others that are worth mentioning since they are often really useful. The threshold tool is a frequently used, useful tool. It basically just says paint every pixel that's between this bottom Hounsfield unit value and this top Hounsfield unit value. And you can tell what your Hounsfield unit values are by hovering over an individual pixel. So you can see I'm hovering here, and if you look down in the bottom left in that data probe section, you can see it says 567. So that's the Hounsfield unit value of that individual pixel, and you can use that to help pick your threshold value. So say we just wanted to threshold out the arterial blood. Well, I kind of scroll over here and notice that, well, it's generally falling between 450 and 650, let's say. So I'd use the threshold tool and drag it to 450 and drag the top end to 650. Roughly. And you can see that we've more or less segmented out our left heart. Okay? You have to click apply to make that segmentation happen and take. Another tool that's useful to know about is the scissor tool. It's not one we're going to use in this walkthrough necessarily, but I just want to go over it real quick because it's a good way to get kind of a quick and easy segmentation. So you just have to read what it's going to do. So I basically want to erase everything that is outside of this heart segmentation. Okay, so I want to erase outside of a rectangle, and you can have it erase everything above or below where you draw the rectangle, or everything outside of it. So let's just do everything. And let's say I do this. Select a rectangle like that. And you can see then that cuts my segmentation across all the slices very quickly. So this is an easy way to just really get things segmented quickly and cut them off and have a nice flat surface as well. A lot of times you want your models to print out and have a flat base, and the cut tool is a nice way to do that. But we're not necessarily going to use that in our tutorial. So I want to delete this part of the segmentation. One of the ways that I can do that is by going to my logical operators section. There's a lot of operations you can see that are available here, but I'm going to clear out the segmentation of my left blood segment. So you can see that cleared it out, and now we're back to having just a right blood and a left blood segmentation. So we're going to start by segmenting out the right side of the heart, and specifically we're going to segment out the blood. And you're going to see in a bit why we do that. And the basic reason is that you'll notice the myocardium of the right heart is just paper thin, and there's not much differentiating it from the adjacent fat or the adjacent contrast within the ventricle. So since it's, and when you get up to the right atrium here, you can see there's hardly any wall at all up by the right atrium. So because it's so hard to segment out the wall, what we're going to do is segment out the blood, and then we're going to grow that out about 2 millimeters, and then we're going to subtract the blood from that grown segmentation, and then just have a thin shell that will represent the right side of the heart. Okay, but the first step is to draw all of these pixels. Now we could just use a thresholding tool. The problem with that is sometimes you select so much that it's a little tough to disconnect it from all the structures that get selected, and a lot of times it ends up taking more time. And so for this particular example, I'm just going to use the paint tool to paint over the regions I'm interested in. And you can see here your diameter is set as a percentage of the screen size, which I tend to use. So 5% makes it that big, 10% will make it that big, 20% will make it that big. We'll just go with 20% for now. Sphere brush is an option where you're actually painting in 3 dimensions, which is really nice. Nobody wants to be painting slice by slice. And then this is a really nice option. It's called the editable intensity range. And that basically says, don't paint any pixels that are outside of the range that I specify. And so this makes sure that you can paint the thing that you're interested in really easily. And so I'm going to do a similar thing where I hover over and I look at Hounsfield unit values for this. And I see that they tend to fall between, well, let's say about 115 and about 330. And this is not an exact science, and it doesn't have to be perfect, and you'll see why, because we're going to use different smoothing and hole filling operations to make our segmentation better. So I'm going to say 115 to 330. So I'm going to drag my slider here, and you can type in the numbers, but that just doesn't tend to work very well. So I am using the dragger. Let's do 120. There we go. To about 330. 340 is okay. All right, so now we're going to paint a sphere brush this size with an intensity range of 122 to 340. That should work just fine. Okay. So I am going to try my best to just outline the right ventricle like this. Yeah, there we go. It's not too bad. You can see I really painted a lot of slices. Now as we're starting to fade out, I'm going to go ahead and paint again. And the segmentation we're going to end up with isn't perfect just for the sake of time, but it's going to be pretty good. You can see it's selecting some things that don't necessarily belong to what we're trying to segment, but that is okay. We'll take care of that in a second. So we're going to speed it up here as we finish segmenting out the right ventricle and right atrium, and then move on to segmenting the pulmonary artery. Okay, now that we have the right atrial and ventricular blood fully segmented, now it's time to create the myocardium, or the lining of the heart. And like I said, the way we're going to do that is by growing this segmentation a little bit and creating a thin shell around this blood pool. And the way we're going to do that is by using the hollow tool. But we need to do something before we can use that first. So what we need to do is we need to copy this segmentation, because we're going to basically hollow it out, and we're going to have a new segmentation called right myocardium. And so the way you do that is you create a new segment and then you copy the right blood over to the right myocardium. So I'm going to click add, and I'm going to add a new segment, and I'm going to make that vein colored since it's the right side of the heart, and we're going to call it right myocardium. All right. So then what we're going to do is copy the right blood into the right myocardium, and the way we do that is with what's called a logical operator. So if you click the Show Details button here, it'll show you how the logical operators work. And instead of using the copy feature, I'm going to use the add feature, because I just think it's a little more intuitive and direct what I'm doing. So add, and you have to read this carefully to make sure you're doing what you intend to do and you know what's coming and what's going. So add will add the modifier segment to the current segment. So what's the modifier segment? The modifier segment is the segment chosen in the list below. All right, so we want to add right blood to right myocardium. So the modifier segment is right blood. And we're doing the add operation. And then it adds it to the current segment. And the current segment is the selected segment, the segment selected in the list above, which is the right myocardium. So let's go ahead and hide right blood. And that way we can tell that the add operation is successful. So once you have your right things selected, click apply, and you can see that the right blood just got moved to the right myocardium segment. Okay? So now that we have it copied over, making it into a thin shell is very easy. We're going to do that using the hollow tool. So make the selected segment hollow by replacing the segment with a uniform thickness shell defined by the segment boundary. And so we want to place a shell along the outside surface, and I'm going to make it 2 millimeters thick. And then you just click apply. And you can see now we have a nice thin wall of the right heart. And if it had been a cleaner segmentation, it would look better, but you can see that imperceptible right atrial wall we've now segmented out as an individual structure. So at this point you may be curious what you've got for a model at this point. So I'm going to switch to the 4-up view real quick, and at any point you can click the Show 3D button to show you a picture of the model that you developed. Okay, so this is our model so far. If you shift and left click, that will allow you to pan, right click, zoom, or scrolling will zoom also, and then just left clicking will allow you to rotate. So that's the right side of the heart. We got the pulmonary artery, we get the right atrium, right atrial appendage, so pretty impressively quick segmentation. Okay, now that we have the right side of the heart segmented out, we're going to segment the left side of the heart. That is a little trickier, mainly because, as you can see, you can actually segment out the left ventricle. There is a myocardium that you can identify. So we're going to segment that out individually and then segment the atrium the same way we did with the right side of the heart by growing the blood pool, and then we're going to combine that grown segmentation from the manual segmentation. So the first thing we're going to do is we're going to segment out that left blood. We're going to do that the same way we did with the right, but we're going to have a little bit different editable intensity range. So we go to the paint tool. I'm going to use a little bit bigger brush, maybe 20. All right. Now what's our editable intensity range? Well, we're sitting between 400 and 610 there. So let's say between 400 and 610. And really the upper range isn't as important. It's not a lot that's more dense than that we're going to accidentally include. But 394 will work. All right, so then we start segmenting out the left side of the heart. Like that. You can see we're segmenting on our left blood segment. So always pay attention to which segment you have selected and which one you're doing the segmentation on. We're going to speed things up here a little bit. You can see we're segmenting out the left ventricle, left atrium, aorta, and the pulmonary veins. Alright, so now that we have the left blood segmented, we're going to do some of the same operations we did to the right side to smooth it out a little bit. I'm going to start by filling the holes with a smoothing operation, closing fill holes, 3 millimeters. Now you can see here that I have an editable intensity range selected. You want to make sure that's deselected, otherwise it's not going to fill any holes because all of those by definition fall out of the intensity that we were painting with. Alright, so you can see that filled it in nicely. Again, if we wanted to make it perfect, we could separate out the aorta and the left atrium and polish it up a little bit, but for now that is good enough. Now I'm going to do a smoothing operation called median as well to smooth things out. Okay, so you can see it makes it, I think it makes it look more anatomic if anything. So now we have a nice smooth segmentation. All right, so now that we've segmented the left heart blood, we're going to start doing the ventricle segmentation. And that's going to take a little bit more. So for that, I'm going to add 3 different segments. I'm going to call one the LV myocardium segmented. That's when we're going to segment the myocardium. And then there's going to be a left myocardium grown, and then there's going to be a left myocardium final. That's what we're going to end up with. Let's just make these all artery red. Select artery, artery. Okay, so the first thing we're going to do is we are going to segment out the left side of myocardium. We're going to use the paint tool, and we're going to keep using a sphere brush and specify an editable intensity range. Now for the myocardium, an intensity range of about 50 to 190 seems about right. So we're going to use that. 50 to 190. I don't want to override other segments, and that should work okay. We're editing the LV myocardium segmented. So let's see how that looks if we just drag it around like that and get the muscles inside the ventricle as well. Not too bad. Speeding up segmentation of the left ventricle as well. I'm going to do another smoothing operation on it. Remove your editable intensity range, otherwise you're going to get unexpected results. Let's go ahead and do fill holes first. Let's try it at 2 millimeters, see what that does. So not too bad. Now let's do a smoothing. Let's keep that at 3 millimeters. Alright, that's quite a bit better. You can notice that the margins are still a little jagged. Again, something you may want to clean up for a final model, but not too bad. Okay, so now let's kind of take inventory of what we have. We have a segmented out left blood pool, we have a segmented out myocardium, and now we're going to try to combine those two into a shell of the left heart with a thick myocardium. Okay, so what we're going to do first is we're going to go ahead and grow this left blood like we normally did. Okay, so that is our left myocardium grown segmentation. All right, so we're going to add the left blood to the left myocardium grown. We're going to do a logical operator of add. We're going to add the modifier segment, which is down here, left blood. No editable intensity range, not overriding other segments. We're going to add the left blood to the left myocardium grown. Let's go ahead and display that so we see the operation happening. So now our left myocardium grown has that segmentation in it. So now we need to make a thin shell out of this left myocardium grown segment. Now if you remember back to how we did this with the right side of the heart, we used the hollow tool to do that. And that is the fastest and simplest way to do it. But for this side of the heart, I'm going to show you an alternative way of getting the same result. It's a couple more steps, but it highlights one of the more useful tools in the segment editor as well. And that's going to be the margin tool, which is going to allow us to grow the segmentation by a specified amount. And then we're going to do a Boolean subtraction of the initial left blood from the myocardium grown to get the same thin shell that we got with the hollow tool. Just demonstrates a different tool within Slicer accomplishing the same effect. We're going to grow it by 2 millimeters. Click apply. Okay, and then we're going to subtract the left blood from it. So we're going to do another logical operator, do a subtract. We're going to subtract the modifier segment, which is below, from the selected segment, which is above. And now we have our thin shell, and then finally we're going to combine that with the segmented myocardium in this final segment. So first I'm going to add the LV myocardium segmented to the final segment, and then I'm going to add the groan to the final segment, and there we go. And you could fill in the gaps there a little bit, but you get the general idea. So pretty good segmentation of the left heart. Now let's see what we have for a 3D model. I'm going to come back up here and I'm going to click Show 3D. Now it's going to show you what you have the eye clicked on here. So it's going to show us this left ventricle without, or the left side of the heart without the right side of the heart initially. You may want to get rid of some of these things. I don't like seeing the cube or the axis labels, and let's make it a black background. And then I want to see the right myocardium segmented out also. And there we go. So pretty quickly, we have a nicely segmented version of the heart with a little more attention to detail, maybe a little more smoothing, some deleting. You know, we could be more precise. But this is a great anatomical model. So once you have your model, the last step is to get it out. And you want to save your progress as well. So, and I would advise saving it more often than I have along the course of this tutorial. But the way you save, you go up to the Save module, and you can see here that this is not the right directory to be in. Slicer folder in beginning. And I just call this MRML file slicer, and that is your slicer file. It contains all the information about your segmentation. And the nifty file is where we want it to be, and the segmentation, this is the other key file, is going to be in that also, because I clicked change directory for selected files. So if we click save, and we go into the 00, we now see that we have our progress saved here. So then we want to generate 3D models. And to do that, we go to the Segmentations module. Looks pretty similar to the Segment Editor module, but this allows us to export STLs. We go down to the Export Import Models and Label Maps, and I want to export models. And I only want to export visible ones. I want to have some control over how many I export, because I have a lot of them. I want to export the right and left myocardium, not all the intermediary steps. And then I just click Export. And now, sometimes in Slicer you click a button and it doesn't give you an error and you kind of wonder what happened. Well, what happened is you need to save those models that you just created. And the default is VTK. I'm going to switch that to be an STL format. So I click Save. Okay, so now we have STL files, and we're ready to do something with those in our next tutorial.